Hello, and welcome to the series of tutorials on photography and associated terms. This tutorial covers the term called aperture. The camera captures image onto the sensor, which corresponds to the retina in our eye. It has light-sensitive material, which captures the image. Sensors will be covered in detail in another tutorial. Aperture refers to the opening which lets light through to the sensor. The diameter of this opening determines how much light is let in. The aperture is controlled by few blades, which close in unison to give an approximate circular shape to the aperture opening. Normally the number of blades are 5 to 6, but it can vary with different lenses and different manufacturers. In this example, we can clearly see how the aperture diameter changes. The opening of the aperture is measured in terms of its diameter and the focal length of the lens. The focal length is the distance at which a lens converges or diverges light. So when mentioning aperture, we use terms like f4, which means aperture diameter equal to focal length of lens divided by 4. The 4 here is known as the f number or the f-stop, which actually determines the aperture diameter. The f number is widely used to denote what was the aperture value that the photograph was taken with. So a lens with focal length of 50 mm will have an aperture diameter of 50 divided by 4, that is 12.5 mm. Some more details about f-stops. The f-stop numbers are fixed based on the power of √2. So the f numbers go as f1.4, f2, f2.8, f4, which is nothing but f√2, f√2 square, f√2 cube, f√2 raised to 4, and so on. These are the standard f-stop values, but the manufacturer of the lens can change it as per his need. So how exactly does the aperture affect the photograph that you're taking? By varying the aperture, you get the effect of depth of field, which is the distance between the nearest and the farthest object in the scene. It helps to gauge the distance between foreground and background objects. The cameras and lenses are designed based on the human eye. So for an experiment, we can try this out. For this experiment, you will need a friend. Now tell your friend to focus on a faraway object, a mountain or a building very far away. While she is gazing at it, look into her eyes and see the size of her pupil. Let her continue gazing for some time. Now while you are looking at her eye, tell her to focus on a nearby object, maybe a cell phone in her hand. Did you notice the change in her pupil size? If you observe carefully, you will see that the size of the pupil increases when you focus on a nearby object. If you try to concentrate on the periphery of your focus without actually moving your eye, you realize that the other objects are blurry. This is exactly what happens in the camera too. When you want a good depth of field, just increase the aperture diameter, which means decreasing the f-stop. If the aperture is open completely, it focuses better on a certain plane and blurs the objects away from this plane. If the aperture just has a tiny opening, then it keeps the entire scene in focus. Here's an example which will help you understand this better. Here are two images. The first one, taken at f5.6, shows how the foreground is in crisp focus while the background blurs out. In the image on the right, you can see how both the foreground and background are in focus. The second image is taken at f16. One more thing that comes up with aperture values is the amount of light that passes through to the sensor of the camera. Again, we go back to an experiment with the human eye. Go out with your friend on a bright sunny day, and after being in the sun for a few seconds, observe the size of your friend's pupil. Now walk into a building where the area is much darker than the outside and compare her pupil size. What do you observe? the pupil size must have increased. When you're out in the sun, it is too bright and so very little light needs to pass through, and so the size of the aperture is smaller. But when you're in the shade, you need all the light you can get, and so the pupil increases in diameter. In the same way, in a camera, the aperture also controls the amount of light that hits the sensor so that you can clearly see an image. In photography, as we have already seen, you can increase or decrease aperture to achieve depth of field effects. But the light passing through could cause your image to be just white due to a lot of light coming in, or very dark due to lack of enough light. There are other factors in a camera which can be used to control this amount of light which passes through to the sensor, like shutter speed and ISO, which we will cover in the next few tutorials. This video shows the aperture being changed on a Canon 50D. So now applying all that we have learned to photographs. There is no specific rule as to what f number you will choose while photographing a scene. If you are shooting a landscape and you want almost everything in focus, you can bump up the f-stop. f16 is considered sweet 16 while photographing landscapes. On the other hand, if you are shooting a portrait, then a lower f number will blur out the surrounding and just focus on the subject. Using a low f number, you can get interesting effects like this one, where the background is totally blurred out. Again, this is no rule. It depends on what you're shooting and what you are focusing on, and what you want as the final effect. The next tutorial will cover shutter speed, which will enable you to get interesting flowing effects, like the ones shown in the picture. Thank you for watching. You can check out photographs I've taken at www.tjthomasclicks.com. Thank you.